Back
So
to
now
you,
we'll be,
Nelson.
thank you. Now we'll be discussing what are the impacts of climate change that we expect to see in the point. Next slide, please. So this project will be working together to address these different vulnerabilities. So the first one, extreme heat, rainfall, flooding from heavy rainfall events, storm surge, which is when you have a storm like a hurricane or a nor'easter that pushes water up and into the neighborhood, and sea level rise, which is a slow increase in water levels that eventually can lead to a high tide being higher and even flooding the neighborhood as well. We'll be talking about each of these as we move forward here. Go ahead to the next. Thank you. So the first one we want to talk about is extreme heat. And we want to start out by just saying that climate change will make extreme heat days, which are classified as 90 degrees Fahrenheit or more, 3 to 5 times more frequent in the North Shore region, including the Point, including Salem, et cetera. So while there are maybe 8 days historically in the recent past, there have been on average 8 days per year that reach this hot level. In the future, there's going to be 23 to even 43. And these will increase over time. And this is what we expect 50 years from now, that the climate will be very different. It will be a lot hotter in the Point. So if you've noticed that the very hot days are becoming more frequent, it's not your imagination, it's actually happening. Next, please. And while I showed you that in the North Shore broadly, the number of 90-degree days is going up, there's also, the Point is already one of the hottest parts of Salem. So this map here shows you the red, those are hotter areas, and the lighter colors, the yellows, et cetera, are cooler areas. So the Point has a lot of pavement. It has a lot of dark roofs. Some roofs have been painted white. There are less trees because of the density. There are less green areas to absorb, to kind of cool things down. So all those pavements and hot roofs, they soak up the heat and then they release it slowly, and that makes the area hotter. It's called the urban heat island effect, and it happens in very dense areas like the Point. So while an average average extremely hot day in the North Shore is actually even hotter in the Point, and even on a little bit less than a 90-degree day, it may be 90 degrees in the Point. So those previous numbers that I showed you, those may be underestimating really the impact in the Point today.
En las anteriores,
Sorry, no, go ahead, please.
En las anteriores diapositivas estábamos hablando que cambio climático puede producir mayor cantidad de días con temperaturas mayor a 90 grados. Pero lo que se sabe es que ahora mismo en el punto es la zona más caliente de Salem. Ya se sabe, por ejemplo, que debido a que tiene mayor número de calles pavimentadas, tiene techos de las casas más oscuros y menos zonas verdes, ya es más caliente que los alrededores. Es lo que se llama una isla de calor urbana. Y lo que sabemos es que el cambio climático va a empeorar la situación. E incluso en los días en los cuales la temperatura no llegue a 90 grados Fahrenheit, en el punto se va a sentir mucho más caliente que 90 grados Fahrenheit. Next.
And so why are we worried about this? Well, one of the main reasons we're worried is that increased extremely hot days has a health impact on people. It can lead to increased hospitalizations and deaths from heat-related illnesses. It can worsen air pollution and respiratory problems like asthma. And some people are more vulnerable to these impacts than others. And many of the characteristics are the same as we discussed previously: environmental justice communities, lower income people, people with higher exposures that live in urban heat islands, and people also that are very young, very old, or work outdoors as well. And in addition to health impacts, increased heat also can raise the cost of air conditioning. At the same time, the other side of that is that, you know, we may have less cost for heating in the winter if it's a little bit warmer, which is good. But the increase in air conditioning and also the impact of heat on electrical equipment can lead to increased frequency of power outages. And when we lose power, that has a lot of other impacts as well. So we'd like to get a little bit of feedback from you in past living in the point or visiting or in your own neighborhood. How has extreme heat impacted you? So go ahead back to your Mentimeter and you can enter your thoughts there. So we see a lot of the impacts already here. We have some health impacts like dehydration or people avoiding going out and exercising. We talked about the economic impacts, the higher costs for cooling due to air conditioning. We talked about, well, encourages you to visit the beach. So there's a good side. We should take advantage of the benefits as well. But less opportunities for exercising, higher energy costs. These seem to be things that people, you know, is very common to a lot of different people. Higher electricity bills, which of course impacts people's pocketbook and their financial health. Other health effects as well, heat exhaustion, feeling really tired in the heat unexpectedly. Well, thank you. It's really good to know that so many people are having the same experience, because hopefully that will be, you know, motivation for kind of participating in this process to help us identify some things that can be done in the neighborhood to help reduce the impact of heat. There are different types of strategies, and sort of some of the next phases of this project will focus on how do we address this. Next slide, please. So another major part of this project is focused on flooding. And I said in the beginning, there are kind of different kinds of flooding that are shown here: rainfall, storm surge, and sea level rise. Next, please. One of the things that sea level rise does, that's the SLR here, stands for sea level rise, is that it's really worsening the impact of these different flood events. So on the left-hand side is kind of like a common storm today. You know, it rains, there may be some puddles on the side of the street. But what we see is that something on the right-hand side, which is today's very extreme event, that's actually going to be the common storm of the future. And so sea level rise is one of the main reasons. It's just making the overall water level higher so that even a smaller storm can cause a lot of flooding.
Lo que queremos ilustrar aquí con estas dos figuras es el efecto que va a tener el cambio en el nivel del mar producido por el cambio climático. Una de las cosas que nosotros sabemos es que al aumentar el nivel del mar, al incrementarse, una tormenta que era muy rara en el pasado se va a volver muy común, precisamente por el efecto del cambio del nivel del mar. Aunque esto puede pasar, este pronóstico es para el 2070, esto está cambiando de manera continua y lenta. Básicamente lo que antes era raro ahora se va a volver muy común, y es especialmente todos estos eventos extremos. Next, Nancy.
And this figure, again, just kind of reiterates the point that an event that is rare today, right? The rare event is like we had in January and March of 2018, where Palmer Cove spilled into the park, right? And affected streets and other parts of Salem. Those rare events have a big impact. But those are the rare events of today. And because of sea level rise, we see that, you know, in 20 years, in 30 or 20 years, those events are going to become much more frequent. And then in 50 years, those are going to be happening all of the time, right? So every year we can expect to see events like that. And so planning for that today makes a lot of sense, right? It makes sense to plan for something that could impact us today, something very rare, but something that can have an extreme impact, and something that we know is going to become even more frequent going forward in the future. Next, please. Now, this project is also going to be looking at how does rainfall affect flooding in the point. And there's not a good existing source of information for this. And the city and the team are developing a model, engineering model, that is going to help us to better understand which areas are affected by flooding from rainfall. And we're not just going to look at rainfall. We know that when there's a lot of rain or there's too much in a very short period of time, that the water can't drain away. It can't come off the streets and then go into the harbor. That's what usually happens, right? We know that when sea level rises, the water from the coast, from the ocean, from the harbor is going to fill up those pipes already. So there's going to be even less space for water to drain, which means that a smaller storm, a smaller rainfall can produce the same amount of flooding as something that's very big today. And we'll be looking again at where are the areas that are impacted by that kind of flooding. And then finally, when we combine sea level rise, filling up those pipes on a daily basis all the time, with a big storm from the coast, bringing that storm surge, bringing that extra water from the ocean into the neighborhood, and also rainfall, that it can actually make water levels even deeper, which poses a bigger danger for people and for infrastructure. So we'll be looking at all these things going forward, but this is an early explanation of why we care about rainfall and how it impacts the point.
Una de las cosas que este proyecto busca entender es cuál es el efecto de la lluvia y cómo va a impactar las futuras inundaciones cuando se combina con los otros eventos de cambio climático. Esencialmente en esta figura hay 3 ejemplos de cómo la lluvia afecta las inundaciones. En el primer caso tenemos que la sola lluvia, cuando llueve mucho, eso llena las cañerías y en algún momento las cañerías no tienen la capacidad y por eso comienzan a inundarse las calles. Lo que pasa cuando la lluvia se combina con el aumento en el nivel del mar es que el aumento del nivel del mar llena las cañerías también. Y entonces una lluvia, así sea muy pequeña, va a producir inundaciones. Y lo que ya sabemos es que además de eso, además del aumento del nivel del mar, existen marejadas debido a una tormenta, entonces no va a haber espacio para la lluvia para irse a ningún lugar y es cuando se producen las mayores inundaciones. Uno de los principales objetivos de este proyecto es entender qué áreas van a ser afectadas por este tipo de fenómeno y crear mapas para que la ciudad pueda responder de una manera más eficiente a estos eventos. Next, Nasser.
So again, in this project, we're looking at all of these different kinds of flooding, all these different reasons why it might flood. We have some existing information on the impact of storm surge and sea level rise, and we are developing information on rain flooding. And then we're going to be looking at all 3 together. But today we're going to be showing you some of this early information on storm surge and sea level rise to start the conversation, to begin the conversation about vulnerabilities, about which areas of the point are vulnerable and how that affects you. So what we're showing here, you can see the outline in blue. These are areas that are currently at risk of flooding from a very rare but extreme event. You know, they could be a little bit bigger than what we saw in 2018. And this is also the same area that is going to be impacted more commonly, you know, on average once every 10 years or so. in about 20 or 30 years, this will become more common. People will experience this while living in the neighborhood. And then it's the very scary part is that this is what we anticipate. This is the same area that we anticipate will be impacted every year. About 50 years from now, this is the area that could be impacted every year. And so we know that that's not sustainable, and we're trying to be proactive. The city is being proactive in helping the community start to plan for that scenario.
Lo que queremos mostrar en este mapa es el área que será afectada por una inundación o por un evento climático grande. En este momento, este mapa muestra lo que sabemos ahora, que es el área afectada por una tormenta muy poco común, parece un poco tan poco común como la que pasó en el 2018. Pero lo que sabemos también es que si no hacemos nada, si no se hace nada, en el 2050 o en el 2070, en 30, 50 años adelante, lo que antes era raro será común. Y esta área que ustedes ven en el mapa será inundada todos los años, probablemente muchas veces. Eso es algo que no es sostenible, ni para la ciudad ni para los residentes del área. Y por eso es que la administración de la ciudad ha decidido ser un poquitico más proactive para empezar a hacer algo para mejorar o aliviar el efecto de estos eventos en el futuro.